Hi everyone.
Hello, good evening.
It's 8 o'clock now. Are we ready? So, uh, hi Serena. Thank you for saying hello on the chat. So you know that on Zoom, the great thing is that we have this chat box, right? Anything that you want to say but shy, don't want to on your video, just type it into the chat box. And today we have fewer people than last week, but the good thing is the session is recorded. So last week's session has been posted on YouTube, which I will, if you don't know yet, I will put the link in the chat box later. If you didn't attend last week, you can check that out. And this week's session, we will also post it on YouTube further down the road so that other people know what they have missed today. So we are discussing working water. And if you have any questions, especially if you're on the OTH pilot program, any questions pertaining to how you measure EC, pH, and stuff like that, Chris will be able to help you with. So go ahead and type those questions in the chat box. Once you think of the question, just type it in. Don't wait, or else you'll forget. So I'm Dorothy. I welcome you tonight on this nice Friday night. Thank you for joining us. So Chris will be taking us through our second webinar of the series, Working Water. Over to you, Chris.
Thank you, Dorothy, and good evening to everybody, and to especially to friends of our Tampines hub. So you need to bear with me for the next 30, 45 minutes during this TGIF, and I hope I will be able to give some shared knowledge, or probably something that you might haven't known yet with regards to hydroponics. So let's start it off. Okay. So working water. Working water actually is derived from hydroponics. So it's a hydroponics is a Latin word. So when we dissect it, it's hydro meaning water and ponos meaning labor. So we're in the absence of soil, actually we're having water work on providing the nutrients, hydration, oxygen for plant life. So this has been well used, especially in urban farming, because it's using minimal space, less water than the traditional agriculture. And by design, it help gardens grow beautiful fruits, flowers in half the time. So having said that, maybe it's, yeah, hydroponic, nice. It's very good, nice technology, a nice design. But let's just drill down a bit on these methods to see if we are really practicing like sustainable methods into farming, or are we just wasting a lot of resource? So there are a lot of hydroponic methods, hundreds, if I'm not mistaken. But those are modifications or of a combination of the six basic hydroponic systems. So let's just cover a bit about those six basic hydroponic systems. So the first one of those six basic is the deep water culture system. So a deep water culture system is seen in this picture. So we have plants submerged, the roots submerged into a nutrient solution. So this nutrient solution now is aerated by an air stone. So without the air stone, this method becomes a different one. It's called Kratky. So Kratky was designed for a single plant. So the root system is constantly submerged. So in the nutrient solution, so it provides perpetual access to nutrition um, for the root system. So one problem with this is without the proper oxygenation, the plant will drown in the solution. So hold on, how can plants drown in a solution, right? Because these are roots anyway. So how can they drown? So they're supposed to like absorb any nutrient that we give them. So it's just like, let me just go back. Okay. So it's just like, for example, um, you are very thirsty and you are in the middle of the sea. Unfortunately, the only water source for you is the ocean. So you drink water from the ocean. You feel like it's tend to quenching your thirst. You drink some more and you drink some more until you expire. You die out of poisoning from drinking a lot of salt water. So in plants, it's quite similar. So if um, the roots get submerged and the oxygen level decreases, the moisture will increase. So when moisture increases on this water, which is now stagnant, so what will happen to the root system is it will develop fungi, right? So once it develops fungi, then onset of diseases. So from the pearly whites root system, you will see it turn brown. When it turns brown, you have a problem with your root system. So the plants will slowly die. So it's low maintenance and good for those who are starting with the DIY hydroponics. This is where I started as well. So a couple of experimentations, modifications. You will be able to learn the basics of hydroponic with this setup. So let's move on to the next one, a wick system. So a wick system now is um, instead of um, aerating the water with air stones, so now the nutrient solution flows from wicks. So these wicks are like highly absorbent material, mostly rope material that can saturate and bring water to your root system, right? So this is a passive type of hydroponics, does not require any air stone, any pump. So it works on its own. A very, very simple setup, right? So each plant has its own wick for its root system. So the only problem now here is since the wick constantly absorbs water, so there's a lot of moisture. So now you will see this like pebbles here, these dots. So these are actually plant medium. So you will need a plant media to support this type of system. So plant media could be like foam, coco peat, mm, those plant media. Let me just go back. Okay. So plants are susceptible to root rot due to it's always damp. So always damp meaning wicks constantly absorb nutrients flowing up to the root system. So next is the nutrient film technique system. So what is this? Let's see from the picture. Okay, so this is something similar that the OTH kit uses. So this will have a water pump which will transfer water through a suspended reservoir. So this reservoir now flows a thin nutrient film. That's why it's called nutrient film technique. And it's a recirculated hydroponic system, meaning water from water pumps flows to the reservoir and goes back down to the nutrient solution reservoir. So it uses quite a number of like water pumps, air pumps, yeah, but it can support a number of plants per channel. So meaning it can be scaled to many plants using the same nutrient solution. So this is the most common technique that you will see in the market today. Even on farms, you will see this. However, a pump failure can be catastrophic, meaning if my water pump like stops working, there will be no film of nutrients flowing to this reservoir. So the roots can quickly dry up. So when it dries up, then plants will slowly die. So as we introduce water pumps, air pumps, then the more complex the system would be. So the next is ebb and flow system. So an ebb and flow system is um, there's a reservoir similar to the nutrient film technique, but this one now fills the reservoir with water and drains it in intervals. So there's a timer which a water pump fills the water, and then the timer stops it. Then the water slowly drains. So this allows oxygenation for the roots because of the constant water inflow and water drainage. So it's just like similar to flushing your toilet. So you flush the toilet, water gets accumulated back. So it's just the same principle. So it's also called the flood and drain system. So it can accommodate almost any type of vegetation, vegetation meaning crops. And again, a pump failure, though it's prone, can be detected because you will be able to see by your constant maintenance, walking around, that there are no water running on or no water dripping from your water pumps. So, and again, one problem that you will usually face with this type of ebb and flow system or a flood and drain is root rot. So root rot is always there because of moisture. So if you will have a problem with your timers, meaning it fills water and slowly drains it, it's not fully drained, but it fills up water. So you will end up with a reservoir on top here, which will have all, always a significant amount of water. So especially when this drain is blocked. So when it's blocked or obstructed and it cannot drain properly, then that's the typical problems that you will face on an ebb and flow system. So the next one is a drip system. So a drip system now, something looks like an ebb and flow, but now this one, the water pump slowly drips water through emitters on the root area. So nutrient solution is slowly dripped into the plant media. So it's also circulated because water collects at the bottom and goes back to the reservoir. So this also can accommodate almost any type of crop that you will plant. So, and can support large-scale hydroponics. So for aside from the NFT, the nutrient film technique, this is another technique or method that you will see on large-scale deployments of hydroponics. You will see a lot of tubes running around the place. So let me just go back. So you see a lot of tubes going to the plants itself. So it's quite complex because you are maintaining quite a number of tubes, and these tubes are thin, so meaning you're prone to blockage. So once it's blocked, it's quite hard to determine which one is actually blocked. So you will end up removing the whole system and troubleshooting from there. So it's quite complex and high maintenance. Okay. Next one is aeroponics, right? So aeroponics is the method that LifePlantz has been using. So we are using it on, with a number of modifications. So the basic simple of aeroponics is instead of putting in your roots submerged, you put a mist of fine particle nutrient solution sprayed to your roots. So the roots are in constant exposure to air. So this allows oxygenation, which results into an accelerated growth. So in 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 the six basic um, in the six basic forms of hydroponics, aeroponics is the one of the fastest that can grow plants because of this constant exposure to air of the root system. And through the technologies of mist atomizing the water, the roots is able to effectively capture nutrients. So it's also the most water efficient in all of the hydroponic methods right now. But then again, it has its problems. So it's prone to pump failures because again, you're having a complex system of pumps and misting novels. So if one of them gets blocked, this is covered so you wouldn't know if one of these portions are not actually spraying or doing the mist properly. So this aeroponics right now you will see mostly in towers. So towers are vertical in nature and they occupy minimal space. So that's why it's quite um, um, mostly used technique nowadays. Okay, so those are the six basic. So what is is there something in common to all of them? So let's just go around the table. Just type in if you see something. Yeah, I see something in common. So just type on the chat window in the set. Yeah, um, you're right. All uses water in a form of nutrient solution. So without the transport of nutrients to these roots, all of these basic systems will not work. So in one way or another, we need to transport water with nutrients to the roots. So maintaining the water quality is paramount. Yes, it's very important in hydroponics because we're dealing with water anyway, or having the water work for us to deliver these nutrients. So the infrastructure is secondary. So water quality is paramount. So without if you have a very good design but your water quality is not that good, then your results are will be gravely affected. So how do we um, check water quality? So are there tools available in the market that can quickly tell me that my water is okay? So what are the tools of the trade? So what tools are available? So there are a number of tools, but first, what do we need to measure? So first is temperature. Yeah, definitely we need to measure temperature, ambient and water temperature. So in this case, we're measuring water temperature. Hmm. Next is the pH or the potential of hydrogen. So this is how acidic or how alkaline, how is the alkalinity of the water. Electrical conductivity or EC is another one. So um, there are some other things to measure like total dissolved solids, turbidity of the water. But in our case here, we will make it simple. we will test the three basic parameters that we would need, which is temperature, pH, and EC. So what do we measure again? Temperature. So water temperature, the nutrient solution temperature influences the oxygen solubility in plant metabolism. So meaning the temperature is directly uh, proportional to oxygen solubility and the plant metabolism. So how fast the plant metabolizes the energy it needs, so it's also affected. So dissolved oxygen on water decreases as temperature increases. So we have seen on our six basic ones that the aeration of water, the oxygenation of water is really important. So dissolved oxygen on water decreases as temperature increases. So that's why we need to keep an eye on temperature, especially when we're running pumps inside the water reservoir. So something that consumes electricity generates heat. So pumps generate heat. So the plant metabolism increases with the increase in temperature, right? So the increased plant metabolism contributes to root fungi and in worst cases, root rot. So plant metabolism means that the transpiration. Transpiration is when it's really hot. So the plants will tend to try to evaporate the water it absorbed from its leaves. So if it's doing it too often, then the root will be stressed. So in turn, it will put in a lot of moisture on the roots, then generate root fungi. So the ideal range of water in hydroponics is about 15 degrees Celsius to 30 degrees Celsius. So that's good because our the climate that where we are is ranging from 25 to 32 in during a hot day, maybe 34 during a hot day, and we're putting this water in reservoirs which are kept not under the sun. So we really need to take an eye on where we place our water or nutrient reservoir on hydroponics because it will greatly affect the temperature of the water inside it because water can absorb heat. So when it absorbs heat, it will heat up really fast when you leave it under the sun. So don't on hydroponics as much as possible. Your reservoir is outside of the elements, meaning the sun or any heat source. So this is a graph showing us the dissolved oxygen and temperature. So meaning we go down or we go up the temperature, our dissolved oxygen goes down. So our dissolved oxygen meters usually reads from 0 to 20 milligrams per liter. So in this case, we will see that the range that we have for when it's water is about at this range 9 to 10. So when we go higher, it at a higher temperature, it goes down to 8. So 30, now it goes to 8. So anything hotter than 30 degrees Celsius gives us not enough room for a saturated oxygen on the water. So pH, so potential of hydrogen. So potential of hydrogen measure is a measure of acidity or alkalinity of water, right? So how acidic or basic it is. So some plants prefer acidic while others thrive on more alkaline water. So an example of which is like a tomato, which wants more acidic, and a um, lettuce, which will go around the neutral point, which is 7, pH 7. So pH level that is too acidic or too alkaline can prevent nutrient uptake, so and results to deficiencies. So later on, we will see a graph showing what are those resulting deficiencies when it is too acidic or too alkaline. So the ideal pH range of water is between 5.5 to 7. So this is the graph that I'm talking about. So the plant nutrient availability. So this is the trace elements that we need for our plants: nitrogen, phosphorus, potassium being the most important. And the thicker the line is, the more the root can absorb. So with this is the range that we want, 5.5 to 7, right? So as we go down, more acidic, so the line becomes more narrow, meaning the roots doesn't absorb as much as it can at that pH level. So we will have nitrogen deficiency, phosphorus deficiency, potassium deficiency below 5 already, right? Mm. And as we go higher, right, higher to the pH range, so our PU or the water from our tap from PUB is about pH 8. So when you Google what is the pH of PUB water, you will see it's about 8.1 or 8. So if we use our PUB water for our plants, it's okay because nitrogen, potassium, sulfur is all on the no problem. It's no problem. However, you see phosphorus, yeah, phosphorus now is starting to decline. So what is phosphorus and how is it? Why is it important to plants? So phosphorus is the plant's ability to store and transport energy, um, and is used for photosynthesis. So this energy is used for photosynthesis. So when we are going down this route of having a phosphorus deficiency, then meaning our plants grows very slow. That's why you will see that if you keep using our PUV water, which is pH 8, our hydroponic plants tend to grow slower. So that's why we need to control pH. We need to maintain it between 5.5 to 7. So next is electrical conductivity. So nutrient solutions consists of charged entities called ions. So it can be a positive cation or a negative anion. This is an ionic solution, the nutrient solution. So the higher the ionic concentration, the higher the electrical conductivity, right? So meaning the more ions or the more cations or anions is on your ionic solution. However, there's a problem. There's a problem there that EC gives no indication of what nutrients or the balance of nutrients of your solution is. So you need to be really careful when you're doing your electrical conductivity measurement, especially when you're doing your own nutrient solution. So you need to put in first, like if you have Epsom salt, magnesium sulfate. So put the magnesium sulfate first, then you will measure your electrical conductivity changes, right? So you don't want too much or too few of it. So next is the NPK, your nitrogen, phosphorus, and potassium. So when you're dosing it, you need to know how much you're actually adding because EC gives no indication of the balance. So EC is measured in millisiemens per centimeter. So let's just take a look now on this table. So this table, something that we have prepared is the basic measurements of EC and pH that we want for certain crops or plants. So most of us do hydroponics putting in lettuce. So lettuce will be at about 1.2, 1.8 millisiemens per centimeter with a pH of 6 to 7. And pak choy 1.5 to 2. So you see pH 7. So that's why pak choy tends to like thrive in any water on the water that we're putting it from the tap. because it's from 7 to 8, between 7 to 8. Mhm. So later on, we'll share you this slide. So don't write it down. We'll share you the slide. So, okay, so now back to the tools that we need. So the tools that we need now to measure temperature is thermometer. So it's in the form of like your cooking thermometers, or this one that you seen before, always targeted to your head to measure your temperature. So don't use those thermometers intended to put in your mouth or your armpit, because it will not measure the water temperature. When you put it on water, it will just say low, so it cannot measure. So don't use those. Use this too as much as possible. So pH meter. So you might have been provided with this type of pH meter or a pH pen, right? And this is what we're using in LifePlantz. So this is a meter that measures temperature, electrical conductivity, and pH. So easy meter, yes. So this is the one that we use. Mhm. So this is the electrode that measures the pH, and this is the electrode that measures the electrical conductivity. So electrical conductivity is just if the water is conducting as much electricity. So those two probes will be able to find it out. So how do we use these tools, right? Mhm. So we use in order to use these tools effectively, you need to calibrate it. So in order to calibrate it, you need to read the instructions that came with it. So normally, for example, me, if I buy something, unboxing, the instructions go thrown away. So in these tools, we need to really read it. So in calibration, normally it's provided with a buffer solution. So, but in shipments, this buffer sometimes is not provided because it's not allowed through customs clearance. So we will always get these meters without the calibration buffers. So if you're lucky enough to have the buffer, then all you need to do is dissolve the buffer in a solution of distilled water. Mm. Immerse it, immerse the electrode um, in the solution, which is now about pH 6.86. Then you just need to press calibrate for 5 seconds and release. And once it's done, it's calibrated, right? So in after usage, these tools needs to be cleaned properly because it has an electrode, meaning it can corrode. So you need to rinse it properly and dry it before storing it. Okay. What if I don't have the calibration buffer? The manufacturer didn't give me the calibration buffer, right? So we can use common household items, right? So if I go around, because my tap water is about 8, right? So how do I bring it down? How do I bring down the pH? So if I look at my refrigerator, the common thing that I will see is lemon or lime. So if I have a lemon and I just squeeze one drop of it, one drop of the lemon's juice in a 500 ml tap, and just settle it down, mix it, it will produce you a pH of about 6.86, right? So use tap water because our tap water is about pH 8. And when you put one drop, it goes down to 6.86. Okay? So sometimes it's really nice to drink a water with lemon, yeah, because it balances out the pH. Then you just press on calibrate and you're good. Then just wait until the calibration is done, and then you can use it for your measurement, right? So what are the common substances that we can use instead of like lemon? So there are a number here, like hydrochloric acid, but that's too acidic. Gastric juice, we don't want somebody vomiting just to give us a pH 1. So the next one is usable lemon juice. That's what we have used in our example. Then goes vinegar, pH 2.4, tomato juice, urine, we want to not use that, so on and so forth. Oh, there's even blood. Don't use blood, please. Toothpaste, yes, 9.9. So you can have a go on testing the pH levels of this common household substances when you have a fully calibrated pH meter on your hand. So now how do we use these tools? So, oh, sorry, going back. Easy meter. So easy meter calibration is the same. So we just use the same 500 ml solution that we have for our pH calibration, and the measure of EC should be about 0.12 millisiemens per centimeter. So be careful of this units because sometimes it's micro Siemens. So it's micro Siemens. You need to multiply it with 1,000, right? And sometimes it's saying CF, yeah, conductivity factor. So conductivity factor is times 10. So you need to make sure of your units. So add 1 teaspoon or 2 grams of Epsom salt into your 500 ml solution that you use for your pH calibration. Mix it thoroughly, have it settle, and you will have an EC of about 2.5 millisiemens per centimeter. So that's how you calibrate your EC meter. So EC meter, unlike pen, the pH pen, the yellow one, you cannot press calibrate. You need to a screwdriver, and you need to trim a potentiometer. You need to trim to adjust it up or down to the range that we need. But a 500 solution of of our tap water with 2 grams of Epsom salt will yield 2.5 millisiemens. Yep. So again, range the electrode and drive for storing. So that's common maintenance of our. So now that we have a calibrated meter, so um, how do we measure our nutrient solutions? So normally you will be provided with A and B solution for a nutrient solution. So you create a mixture as per the instruction. Sometimes it's about 200 ml 200 ml per one liter, 200 ml per 1 liter of A and B of water. So once you mix that, you will have a pH of about 5.6. So this A and B solutions already gives you the 5.6 pH that you need, right? And the EC produced by this A and B solution, if you will follow the instruction 200 ml per 1 liter of water, you will give you about 1.5 millisiemens per centimeter. So if you go back to our graph again a while ago of what plants can I grow in 1.5, so those are the basic ones that we have now. Green leafy vegetables. Yep, 1.5 millisiemens per centimeter. So we have made our mixture solution, a nutrient solution already, right? So we put our plants. Our plants has been growing good. So how do you keep them alive, or rather, how do you not kill your plants, right? So there are some tips here, like pH and EC values changes over time. It does not it does not change really fast unless you put in something there in large amounts that changes the quality of the water. So when the root system is already well established, when you pull out your plants, you will see a very long root. So it's okay to prune these roots, cut them down, cut them only to the point where it's touching the nutrient solution. So we don't want them growing really, really far until our reservoir. So it will clog your pipes. So these roots can clog pipes, right? So at least for after 2 weeks, you will see the roots already grown. So you need to start pruning roots after a week or 2 weeks. So it's okay. You're not hurting the plant. The plant remain stable as long as the root system is touching the nutrient solution, right? So when the pH is swinging from acidic to basic, check on the root system, as this could be an indicator of root rot or even algae, right? Algae competes with oxygen, so they thrive on oxygen, and during nighttime they will produce carbon dioxide. So cut the roots, um, turning brown. If the roots are turning brown, cut it up. Top up the water. 50% water change is advisable at that case. So when your EC is going down, your plants are very, very hungry. They're eating a lot of nutrients, right? Yeah. So do your root housekeeping. We don't want too much root system that it absorbs a lot of nutrients. So it's a matter of controlling the plant's appetite right now by cutting down, pruning the roots. Mm. So there's some work to be done, and it's just not a plug and play system. So you put a plant, you need to take care of it. A part of taking care of it is actually checking on the roots health and pruning it when needed. So an increase in EC could be due to transpiration. So transpiration again is the plant is getting really warm. So what it does is it uses a certain amount of water and it evaporates it using the leaves. Yep. So check your water level regularly. Otherwise, you will end up with a low water level. So some bonus round. So I do not have a pH meter. Is there something in the house that I can use? Yes, there is. If you don't have a red cabbage, you go out in the market, buy some red cabbage, half or some, then you just cut it, put it on hot water, let it cool, collect the water and the juice, and you can use it now to detect pH. So this is a range of what color it will produce. So the pigment reacts to acidic or basic solution. So when you put in something acidic, the water that you collected from the red cabbage, actually the red cabbage color is about this stage from violet, right? So it will change from purple to red. And if it's basic, like if you put in baking soda, then you will see it turn blue or even blue-green. So red cabbage, very good in if you don't have a pH meter on hand. So I don't have a nutrient solution. Is there any alternative? Right? So there is, yeah. So you can use a bunch of household materials like dried seaweed. So don't use the ones that are salted, the ones that are already for consumption. So dried seaweed on its purest form is a very good nutrient source. So boil it in water, filter the water, collect the solution, dose it with a bit of Epsom salts and PK in small amounts. You have a pH and EC meter, right? So you can monitor how the pH is affected and how the EC is changing once you dose a bit of this. So the key is dose in little amounts. So you will see the changes, minute changes. Don't put in too much, because once you put in too much, then it's hard to roll back whatever changes that you have done. So monitor each increments with your pH and EC meter. So um, that is all for tonight's water works. Consume about 47 minutes of your time. So let's have a go for questions at this point.
Thank you, Chris. Actually, after hearing your what you thought, I've got a bit of a headache.
Is it too much technical?
I think for some people they would love it, but for me personally, that's why I prefer growing in soil over hydroponics. 'Cause
Yeah, there's a balance that still really needs to be maintained. So we only talk about pH and EZ, electrical conductivity.
yeah, and there's that
Um,
more.
Yeah, there's more. Yeah.
Reminds me of some people say the difference between chef like cooking over baking. The difference is a bit like growing plants in soil and growing in hydroponics. Like if you're cooking, you can just add salt like oh this
Yeah.
is I think this is how much salt you should get like that.
Mm.
But if you're baking, you can't do that. The product comes out is not going to be the product you think it would be. So I think hydroponics is a bit like you need to have a bit more precision. So let's look at some of the questions. Da, 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 da. Uh, okay, weak system. The media can be lacquer balls. Is it effective? Which veggies can grow that way?
Yeah, so for the weak system, it's advisable to have because leakables is depending on the size and absorption of uh, water. So you might need to put in something else with the leaka balls like pumice, volcanic rock, to help on absorption, right? Because the leakables alone will not absorb that much from the wick unless it's fully saturated already. So what type of plants? So in wick system there are the choices are limitless. The one that I've shown you on the list from root crops, from to green leafy vegetables to flowering plants. You can put it on a wick system. Um, the one very familiar system for us would be Click and Grow. So Click and Grow uses a wick system, but their media is coconut fiber, coconut peat. So that's why it's high in absorption. So the only problem now with this is they have a very small pot, which cannot grow like very big plants. So it depends on the size of the pot that you put it in. If you don't use a pot, you just straight away put your plants on your leakables with volcanic rock, humus, then it's okay. They will grow. Mm.
Okay. So that was a question from Serena's iPad. So Terry Teo asked about the same question. So you've got your answer. Next, where can we get the nutrient solution that is safe and organic? Because we're dealing with edibles, is it possible to be chemical free?
Uh, if you want an organic, so you need to like do a DIY it, because if it's a solution A and B, those are chemical, those are trace elements that you're mixing together, so it's not really organic. You're dosing it with like how we drink vitamins. So our vitamins usually is most of the time non-organic. Like it targets vitamin C, B complex, those kind of things. So it's similar to nutrient solutions. So when you really want an organic one, then you would really need to DIY. I don't know, and I cannot recommend any organic hydroponic solution right now. But I can suggest like the last on the bonus round, like using seaweed, dried seaweed, fish emulsion, Epsom salts. So as long as you have the right tools, your pH and your EC meter, you'll be able to concoct your solution, and you'll be able to use it. Mm. So once you have measured it, you can recreate the same solution every time. Mm.
So on the market, there is no organic nutrient
There,
solution.
there are. Yeah, but right now I cannot recommend any. So I always tend to suggest DIY it if you have your tools already ready with you. So you will be much more at ease of what you're using,
Yes,
because yeah,
because you know exactly what you put in there.
yep. Mm.
So we've answered Serena's question. Jean Xiao asked, how long can the pump be switched off safely for the plant? I guess, but with regard to which type of system, Jean, um, if it is the nutrient flow, then you cannot switch off the pump. Is that correct? The
Yep.
anti-gravity.
Yep. Okay. So most of this from aeroponics to the nutrient film, you
Okay.
really cannot switch off the pumps. It really need to run 24 by 7. So because they don't have media, but if you are using a media which can saturate in water, like for example, our LifePlantz, our LifePods actually uses coconut materials on the pod. So we don't really run pumps continuously. We can stop it in intervals because once we saturate the media with water or nutrient solution, we can stop it. So hence we came up with the start kit. So a start kit is the good example of that. Our start kit, we just spray it every twice a day with the nutrients. So it doesn't have a pump, right? So we just saturate the media with as much water as we can to last through the day. But if you don't have a media, then you need to run your pump 24 by 7.
I think maybe next week we can do a demo with your start kit and also do something regarding germination because
Yeah,
that's not the
yeah, that will be good because next week will be plant media. So we can show you the media, plant media that LifePlantz has been using. So how do we apply it on our start kit? How do we saturate it with water? And how did we test it like twice a day? How did you came up with twice a day of putting water on your medium and just let it grow? Mm.
Okay, so in short, for those who are using the OTH hydroponics kit, that's a NFT system. So don't switch off the pump. Okay, so this is a question from me. So if the water gets too hot, does adding a air pump help? So because just now you were talking about when the water temperature is hot, the oxygen level goes down. So in Singapore, it's so hot, and then if we have the hydroponics kit, let's say in the balcony, where it can get heated up. So if I have an air pump, does it help?
So one air pump doesn't really help on bringing down the temperature, right? Especially when you have a pump inside your recirculated system. So it's actually a combination of the weather. So how hot is it on the location that you have put your hydroponic kit and the pump that is running. So the pump, if it continuously run, it will continuously produce heat, right? So if you don't have a pump or you're using a DWC, just an aerator, try to use a reservoir that does not uh, gets penetrated with heat. That so you just put it with some insulation, the ones that you can buy at Daiso. So that's a good insulator of heat, so that you can at least control the temperature of your water reservoir. So having said that, so once your water heats up inside, so it's really hard to control, especially on this setup, the DWC or Kratky, because it's quite hard to determine what temperature is it right at your reservoir. Mm.
Oh, okay. So we should move the reservoir away to a place where there's is not directly heated by the sun to keep it
Yep.
cool.
Or use insulation materials that you can buy. You know those silver with
Yes.
small foam.
Yes.
You can use that for insulation. That is a very good insulator of heat.
Okay. All right. Okay. And yes, Jean, thank you. Yes, the pump will generate heat as you have commented. All right. Serena is asking if too alkaline or acidic, what can we do to get the right pH? Uh,
Okay. Mm. Yeah. So there are um, available in the market where you can buy some pH up, pH down, but I don't recommend you using that because they use sort like if you do a pH down, they use citric acid. So citric acid produces uh, calcification on your system. So the first thing to break down is your motor, one or your pump. So once calcification sets in, your pump just ceases to move. So, and if you have small pipes, your pipes will also calcify, and it's very hard to clean those pipes when it gets clogged. So my suggestion is to really do a water change, a 50% water change. So if anybody here is doing aquarium, so freshwater aquarium, so the first part that you will really do to solve this pH problem is to do a water change. So water change, don't waste the water. Use it for like watering plants, flushing your toilet. So don't waste the water. But a 50% water change will really help on adjusting back your pH.
Okay, all right, that's good advice. Uh, oh, Eugene was asking the OTH kit does not come with air pump. Is it needed? Well, I think we addressed that is not needed. Yeah. But also somebody remarked further down that when you let the air flow in, like gush in, it also helps to dissolve air into the water.
Yeah, yeah. Some actually I've seen that putting electric fans or small fan, those computer fans, rechargeable fans, on the reservoir. However, that causes a lot of evaporation, so especially when you're on a humid, hot place. So if you do that, you just need to watch out about evaporation.
Okay, the water level.
Yep.
Okay, all right. The solution usually comes all mixed up. That's Serena's question. How to measure the individual elements? If wrong EC numbers, how to get to optimum?
No, you cannot measure the EC uh, balance for each of those nutrients, for each trace element. So you can only measure it if you're doing your own formula. Like I have an NPK, so I slowly put in the nitrogen and measure with my EC what is the changes. So that's the only way you can measure. Then you go to the phosphorus, potassium, so on and so forth. But if you're looking into a solution already, an A and B, you would really not cannot measure what is the balance of those trace elements.
So over time, when the plants drink up the nutrient solution, they may have drunk up more of one nutrient over the other. So to get it balanced, the only way is to just change out the water and remix from scratch, right?
Yeah, if you see your EC going down, so assuming that it's not due to root rots or any disease, so it could be your water level is going down, so you need to top up your water. When you top up your water, you will see your EC going down, so you need to put in more nutrient solution to balance it back to the 1.5 or 2 millisiemens per centimeter that you need. So having this calibrated tool or meter is really important.
Okay. So I guess that's why after one cycle, when the veggie has already grown and you have harvested it, it's good to do a changeover, like totally empty the reservoir and remix a fresh nutrient solution. Is that correct? So that you know that you have it in proper balance.
Yeah. So what would I suggest is because we don't want to waste the nutrient solution that is still usable. So we need to inspect the water, the nutrients, after during a change or during a maintenance. So you need to observe what is the condition, what is the water, does it have any buildup of salts, calcifying. If not, you can reuse it 20, 30% reuse whatever you can reuse from that existing nutrient solution. There can also be pathogens already existing, like
Yeah.
due to root rots. So if you didn't encounter any root rot, then it's good to reuse. But if you saw already onset of root rot after you do your harvesting, the roots are already turning brown before you harvest, then don't use that nutrient solution anymore because there could be fungus or pathogens already on the water.
Okay. Um, Another question from Serena. How often should we check the EC and pH values and top up water once a month?
Okay, so for measuring of pH and EC, normally when you do your A and B solution, it will take you about 2 weeks before your plants even grow a sturdy root system. So once the root system is there, you need to start measuring. So that's 2 weeks after you do your A and B solution, assuming that you're germinating from your kits. After 2 weeks, you start measuring. Then every week you do your measurement. So after 20 days, you will see your water reservoir will start to go down, maybe 15 to 20 days. Because the root system is already established. So that's the part where you really have to take a look on your water reservoir. You don't want it to deplete, because when you deplete it, you lose nutrients, or maybe you concentrate the water, the nutrient solution. So after 15 to 20 days, regular measurement like every week is required.
Okay. All right. We have quite a number of questions. I should go faster. Can we use, Jean is asking, can we use the blue pea flower to put in the water to increase the pH?
Which one? The blue? I sorry, I don't know how does that particular substance affect pH. So I cannot comment.
Oh, okay. All right. So, Jean, we don't know how about the blue pea flower. Maybe you can do an experiment and let us know. Okay. How often, Eugene asked, how often should we change the media and seeds for OTH hydroponics kit?
Yeah, so the OTH kit comes with a pot. So the pot, usually you will put foam. So that foam is not the media, it's just to hold the plant in place. So if you're talking about media, these are like coco peat, leca balls, volcanic rock. So if you're using this media, usually the media will stay throughout the life cycle of the plant, which is about 40 days upon harvesting. So only after 40 days, you will start to clean back this media to make sure that there are no fungi that are left over after your harvesting.
So the foam, can it be reused?
No, the foam cannot be reused. Only like balls, coconut media, volcanic rock, because the foam is not a media. It's just used for the germination and to hold the plant in place, right? Yeah.
So after harvesting, the foam needs to be thrown away and need to use a new foam or change to a media.
Yep.
Okay. Next question. What if Jean asks, what if there is a power trip and it goes off overnight? How much harm will it be done after, say, 6 to 8 hours? Oops.
Yeah. So in the OTH kit, it's a NFT. So once you lose power, the plants will start to, assuming that you're not using any media, so there's no water retention on your root system. So it can dry up really quick in 2 to 3 hours. So if it's in the middle of the night, once you wake up, the plants are already dead.
All right, so try not to trip it. Debbie asks, so can we just add ice cubes to the water to bring down the temperature if the weather is too hot?
Yeah, this is a nice question. So plants doesn't like a very rapid change in temperature. It's because we have covered that temperature, the pH and the EC, the ions. pH is hydrogen ions. Nutrients is a bunch of ions too. So it's affected by temperature. So if you quickly make a water cold, so that affects these ions. So it affects pH, it affects EC, right?
All right. Chiang asks, can a hydroponic system work in a greenhouse?
Yep, it can on a greenhouse. Yep, it will definitely work, because a greenhouse is intended to shelter your plants from the elements like too much wind, too much rain, water, too much sun. So the greenhouse will retain as much moisture and the temperature inside it, so it will thrive on greenhouses.
Although I must add that you must make sure that there is good air circulation. That's an experience we had with our green hut in
Yeah, we
in
don't want it to be like an oven, so we need circulation.
yeah, we started off without air circulation, so it was like too hot, so we added fans.
Mm.
Okay, Chua Ching Xia asked, may I know what is the reason not to switch off the pump at night? So, you know, if you have been listening, it's because I know that Chua, you are using the OTH system, right? That's an NFT. So you have to keep the pump running or else it will dry up. So Chia asked, can pond water be used with a hydroponic system?
Like what water?
Pond, like fish pond
Ah,
water.
fish pond water. Okay, so fish pond water, we don't know what type of pathogens are in there. So fishes, we don't know their health. So if it's your aquarium and you trust that your aquarium is really healthy, you can use it. However, if pond water, you might be importing some other things on the water on your system. So don't do that.
Yes, good advice. Eugene says better invest in a standby water pump just in case of power failure. Yeah, yes. So if you're afraid that your the pump dies in the middle of the night, 6 to 7 hours, not enough time to save your plants, maybe have a standby pump, yes, to kick in. So thanks Serena. Uh, and Eugene, please recommend water pump specifications.
Oh, water pump specification. So once these are for the OTH kit, right? So we have the OTH kit already on our workshop. So we will be tinkering with it and looking for ways of improvement, like water pumps. Can we switch off pumps for this type? So we will be doing our recommendation in the few weeks time. Probably if we're able to get some data, then on the next session, which is plant media, then we will be able to include it.
Okay, thank you very much. If you guys have noticed behind Calvin's, there is a, you can see the voltage hydroponic set just behind him. So he has got a sample there, and that's what they'll be tinkering with, and then advise us in the next few webinars. Okay, last few questions. If the media, Debbie asked, if the media will help to retain water, means having it will be safer in case of power trip. Is that right?
Yep, that's completely true. So if you're using a media which has a very good water retention, so it can last you for 6 hours, even more than that, if you have a very good media to support your root system.
So come back for next week's webinar on a recommendation on what media to change to next after this first harvest when you ditch the foam, what media we can change to.
Mm.
All right. I think if we have the foam, it will hold water for a while from Serena. Yeah, the foam cannot hold water, right?
Yeah, this type of foams usually evaporates water really fast.
Mm.
Yeah, because the intention for this foam is to hold the stem of the plant and only submerge the root. So that's the purpose of this foam.
I guess with the water media that can retain water, there is the problem of root rot. If too much water is retained.
Yep. Yeah.
Yeah.
So it's still a balance of what type of media. So we still want better aeration, because if it's too humid, the root rot will set in.
Okay. Thank you so much for your advice, Chris. I think we've come to the end of the questions. And before I hand this over to Kelvin, let me say something about the pH meter that was given to the hydroponics pilot program folks. I think there was a misunderstanding previously. Tony was telling me that can also measure EC. So I will do a correction in our private FB group. That is a pH meter, cannot measure EC. But Tony has a way of doing his EC measurement. So let me consult him and find out from him how he does that. So that's something else. So that's pertaining to a pilot program. But if you want an ECN pH meter, I think the one that Chris is using is better. It looks more expensive also.
Yes, and it comes calibrated outside off the factory,
Oh,
and we usually maintain these tools for you.
mm.
So if you really don't trust the reading, we can drop by and just calibrate it for you.
Okay, so for anyone who wants an upgrade, ta-da! All right. So, Kel, what do you have for us today?
Lucky draw time. I hope nobody is being locked up in the library again tonight.
Oh,
So, and please remind yourself not to use blood to change your pH level, please. Come on, please. So I shall not hold too much time. I just like to see everybody's involvement on the chat box. Give me a yes if you like to do group buys. If you like us to arrange group buys. So type yes. So wow, great.
Yes, for
Yeah.
me.
Yep. Great, great. So type a yes if you like us to arrange group buy. So what Dorothy, myself, and Chris we are working on is to have an FB Facebook community page, so all of us can actually arrange group buy from there. So along the week, from last week till now, I have emails coming in. I have emails from Eugene. So we touch on the pH level today in our webinar. So I hope we answer some of the questions. I have a question from Desmond. Desmond about kids with LED. Since last week was all about LED. So yes, we do have kids with LED. So I try not to promote too much right now. So when we arrange a group buy, so we can actually work with Dorothy and the OTH team. When we do a group buy, of course, discounts are there. So even things like LED, it could be the measurement tool, things like that. So I see a lot of yeses, so we will do that. If you have missed out last week's webinar, you can find us on YouTube. So just type the keyword LifePlantz, plants with the letter Z at the back. So we are on YouTube, so the lessons are there. Same for today's lesson. We're going to be uploading, give us about 24 hours, 36 hours. We'll put it online, put it on YouTube. So most of the questions are there. So along the week, just email us. And congrats, congratulations to last week's winner, Elaine, Sharon, Victor, Muhammad Muaz, Bernice, congratulations. So what you guys have won, I hope you guys have got your start kit. As Chris mentioned earlier, we use a start kit when the course comes, when the webinar is touching on germination. So we actually use it. So tonight we're gonna draw another 5 lucky winner. Anyway, I hope you guys have received it. You should receive it by today. The last week's winner. Oh, thanks, Victor. I saw your text. I think you received it today. So except one guy, I think you live in Choa Chu Kang. I think you will take Ninja Van quite a trip to reach Choa Chu Kang. So, I'm really amazed that we have Choa Chu Kang audience here for OTH. So again, lucky draw time. So attendees, all the names that you have registered, they are all here. They're all here. So hope you can see me. A bit small. I have a first winner for tonight, Linda. I'm not sure if the cam can catch it. Linda, trust me, I'm reading it. Linda Leong.
okay, I can see Linda. I can verify that.
Linda Leong, congrats. If you're still around. So all these names are for you who have registered. Cheryl Lee, I got Cheryl Lee. Congrats, Cheryl. Cheryl, not sure how good the cam is. Cheryl Lee, congratulations. We'll send you a start kit. Again, I'm not peeping to make it fair. Doesn't mean if you joined last week, you won't be. If you won last week, doesn't mean that you won't be picked again. You may be that lucky you pick again. Yep. We hope to give you another kind of seat if you are being picked. We have Vera Chai. I hope I pronounce it rightly. Vera Chai. So I got your email address. So I'll send you the kit. I'll write you. Linda, Cheryl, Vera Chai. Let's see. Chang SL, Chang SL. Congrats, Chang. And one final one. Serena Low. Serena Low. Serena Low, I think you are Serena with iPad 2, right?
Yeah, that's Serena.
Yeah, so I guess so. Oh, congratulations. Oh, Cheryl, welcome, Cheryl. So what you guys gonna get is actually our start kit. So when we're gonna go on germination, Chris will touch more about start kit, like what Chris mentioned earlier. This is a bok choy, so you can see that. So that's all from me. Congratulations. See you all. Keep the emails coming in. We'll update everyone when the Facebook page is up, when we are organizing any group buy. Just drop any comments, any feedback, things that you like us to touch on, things that you like us to arrange group buy for. And as Dorothy mentioned earlier on my back, so we just received the kit, the hydroponic set. So Chris and myself, we're gonna play with it. So we're gonna play with it like what Chris mentioned earlier. I'll bring a close up to everyone. So this is very much our aeroponic set. So our home kit. So we are doing tests with it same every day. Sometimes we test pH level. We test like, do we keep the pump on? So everything you guys ask are very technical questions that I ask a lot. I ask a lot to Chris. So keep the questions coming in. Thank you.
Oh, before we say good night, a quick answer to Jeremy who was asking, just curious, the hydro set behind the lights height, are they adjustable? Are you asking about the voltage set? That one was the demo set that was shown to everyone during the briefing. So that is not adjustable, the height. But I think Chris and Cal is going to tinker with it to see what they can do.
Yep, we'll try to find ways.
And the voltage set is hydroponics, whereas what Cal showed you guys is aeroponics. So it's very exciting to compare the two. So more exciting topics upcoming. Stay with us. Thank you guys.
Thank you.
Thank you very much.
Good night.